Okay, so in this video we're going to be making a simulation of a network, and we're going to be doing that by using the Riverbed OPNET network simulator. So why don't we go ahead and get started here. I have created a palette already with my individual node models, so if I just change the view it brings me to this nice view, and I've added all these nodes to make our network model. Now what we're gonna do basically is a design of 5 workstations, and they're going to be contacting one another through peer-to-peer communication. And then the next thing we're going to do is we're going to make them communicate to a server, and then we're going to implement a firewall to that server, and we're going to analyze a lot of data, such as delays, packet loss, sent versus received traffic, and we're going to be applying different scenarios. So that's what we're going to be doing in this video. Okay, so in order to make this network that we have theorized, I have to use these two nodes called profile definition and application definition. So let me just rename them. Application definition and profile definition. So we'll see that within the application definition there's a couple of options, but the option that we're worried about is the application definitions, hence the name application definition. So, and I can select multiple application definitions. So if we look here, and I can call this whatever I want, depending on, to make this easy for myself, I can call it a name similar to whatever I select here. So we see here things that we're familiar with: database, email, FTP, HTTP, print, peer-to-peer, remote logging, video conferencing, so on and so forth. And also I can select multiple of these, so I can have a number of rows, up to 3 here, each with different descriptions. So now if we look at profile definition, actually we'll see that we only have this option, which is the profile configuration, and I can select specific applications that I previously made in the application definition. And in fact I can select multiple of them by adding extra rows here. So if I add one, I would have to enter the name here, but I don't have an option right now because I haven't created one. So let's go ahead and do that. Okay, so I'm going to start placing down some elements that I have here before I configure the application definition and the profile definition. I want to place down everything. So I'm going to be using these mobile workstations, and basically it's going to be about 5 of them. Okay. And then this is going to need a router. So I want to place down a fixed router, and that's where this comes in. And then we want a gateway, so we're going to choose the Ethernet 4 slip 8, and then we choose our firewall, and then finally we choose our server. And I'm also going to rename all of these elements here just to make it clear. This is the server, firewall, gateway, router. Okay, so and then I'm going to leave my workstations just how they're named They're named mobile node 0 to 4, so that's in total 5. So let's start with the application definition. I'm going to select my number of rows. I just want one application, and then I'm just going to call this file transfer heavy, because you'll see here I have a list of items, and we can start off with HTTP and call it heavy browsing. In fact, we should actually start with peer-to-peer file sharing instead. So we turn this one off, and we choose high traffic here. Okay, so now the application definition is set. So now we go to the profile definition, and we select profile configuration. And in the profile configuration, we want the number of applications. But before that, we have to name it. So let's call this wireless communication. And then we want to have one row. And then here, we'll see the application that we previously defined. And then in repeatability, you want it to start once at the start time. And press OK. So now we move on to the server. We go to Applications. We go to Supported Services. We go to Edit. We add one row. And then we see a drop down. We select the application we defined. We press OK. And that's good for the router, the server. So now we move on to the router. So in the router here, we want to go to wireless LAN parameters, and then we go to the BSS identifier. We just call this 1. BSS is basic service set for networks. It's like agreeing on a radio frequency for communication. And then we have a data rate, and you can just call this 1 for now. So then we go to the workstations, but we want to select similar nodes, that way they all get selected. And then we go to Edit Attributes. And then in the Applications menu, I want to go to Supported Profiles. I want to add a row. Call it 1. And then I want to select the wireless communication profile that I created. And there it is. Press OK. Actually, we're not done yet. That's the airplane overhead. So let's keep going here. We also want to go to the BSS, the basic service set, and make it 1. That way it's, it knows that it's communicating with the router. And then the data rate, we want to change that to 1 as well. Okay, and then all that's left now is just making the connections where they need to be. So this is how we do this. We use this 100 base T connector. Okay, there are no changes required for this gateway, in fact, so we should be good. And as far as the firewall is concerned, let's say we want to change some settings. We go to the proxy server information, and then here are all the different types of applications that the firewall is deployed for. For instance, let's say I want to block HTTP. I can simply say no in the proxy server deployed section here and press OK. And that will effectively block any HTTP that comes into this network and attempts to go to the server. Okay, so before we continue, actually, later on these workstations are going to be moving so they're not static. These are mobile workstations. So what I'm gonna do is I'm gonna, and they might go further than the wireless capability. So what I can simply do is go to Edit Attributes, go to Wireless LAN, and then the parameters, and then I want to increase the power rate. Let's just put it at right there, 20 milliwatts, right there. And then we apply to selected objects. So actually, I don't believe I ticked this off last time, so I'm gonna tick it now. So let me check. Okay, so if you have any doubts that you set up your workstations right, I just went ahead and double checked it. I had to fix it. So basically you want to have in your applications menu, in each one, in your supported profiles, you want to see that you have your profile selected. And in your wireless LAN settings, in the parameters, you want to have the BSS identifier 1, the data rate 1, and you want to increase their power to 20 milliwatts here. So basically you want to check that they all have that, and if they do, it's all good. So now we move on to statistics that we need to select. So let's go ahead and select some statistics. Now I already selected a lot of statistics actually, so I'm going to unselect some of these and I'll do it from scratch basically. Okay, and in fact I'm probably going to select more this time around, so let's go ahead and get started. So the first thing, I want to look at email. I want to look at traffic received, traffic sent in bytes per second. I want to look at Ethernet, so delay. I want to look at FTP. These are the different types of applications that I'm going to be using throughout the simulations. And then I want to go down to peer-to-peer file sharing. Basically the same information, bytes per second, and traffic sent. And then we go down to wireless LAN, and then I want to look at data dropped. The data dropped, both of them. I don't think I'm going to be looking at this, but this is good information to have, because we are going to run through a lot of scenarios in a row, and we're not going to do an analysis until all of the scenarios are played out. So we do the simulation once for each scenario, and then we look at the graphs. Okay, so we look at the node statistics now, and then again we want to look at client email. We want to look at basically all of these four. Same with FTP, HTTP, and we move on to the server email, server FTP, HTTP. We move on to wireless LAN. We have data traffic received, bits per second. We have data traffic sent. We have delay, queue size, retransmission, and throughput. So now we move on to firewall here. So we press OK. And then we want to choose some statistics for the firewall here. We want to look at incoming traffic for the firewall. And so we're going to go to node statistics. We go to Ethernet. Where is it? Right here. And then we go to load in bits here. Bits per second. we go to load in packets per second. We go to traffic received in bits per second. As well as this one. So this tells us the information that arrives at the firewall. Okay, and we press OK. So we make sure that we selected our stats, and there they are: client, server, and then LAN. And then we have global statistics, we have the email, Ethernet, FTP, and then the LAN once again. So that's good. Okay. Okay, so let's look at the scenarios now. And in the scenarios, I want to have quite a few scenarios, but I want to name them with the sort of applications that I'm using, you know, the characteristics of the firewall and like the speed of the CPU that I choose, but also whether or not the workstations are static or mobile. So let's start with that. The application definition currently is peer-to-peer, so we're going to write that down. The firewall is blocking HTTP, so that's good. Our CPU speed is just 1. That's the multiplier of the CPU speed. In case we want to change it just to look at how the graph behaves, we can in the scenarios. We have the naming convention for it. And then this 1_1 is basically the data rates of the router and the workstations. I can increase them or decrease them however I want, but we don't really need to. But if you're curious what changes happens, you know, you can change them. So that is the first scenario, and then I press OK, and then I run it. And then the duration of this is going to be 7 hours. This is the seed that I'm using, and then the updates. So let's run it. Okay, so the simulation is complete now. We're not going to worry about the results yet because we're going to go through a lot of them. So let's go through the application definition, and let's change from peer-to-peer to email. And then we turn this one off. We go email, high load, okay. And then we go to scenarios, we duplicate scenario, and then we select the portion that we're changing. So we've changed from P2P to email. So let's press that. Let's press OK here. And then let's run it. And we're going to be, basically we're going to keep doing this until we go through HTTP and FTP. So we started at peer-to-peer, then email, then HTTP, and then FTP. And then we're going to make the workstations mobile. We're going to make them move around. Okay, so now we go from email to HTTP. So let's go to settings here. Okay, and I already have it selected actually. So yes, I had selected it already, I mean. So let's keep it there. But then I want to go to my scenarios and I want to manage it. No, I don't want to manage it. I want to go to duplicate scenario. And then what I'm going to do is I'm going to rename this to HTTP. And then you'll notice that my firewall blocks HTTP. So we should expect the firewall to block HTTP communication that goes to the server. So let's press OK. And then let's run it. This one shouldn't take long. Okay. New scenario. We are going to do now FTP. High load. Scenarios. We duplicate scenario. FTP. Okay, we run it. Oh, here it is. It was open on my other monitor. And so now that's complete. So now what we're gonna do, we have our scenarios ready for the static. They're all the data is saved. So now what we're gonna do is we're gonna introduce movement into the workstations. So now we want to introduce movement into this. Let's start with this one here because I want all of them to have different movements. So let's define a trajectory, and then we want to define a path. Let's see. Let's just call it Roam 1 or Roam 4. And I want to continue, just bring it around the router like this. And then we complete it. And then this one, let's define this one. Let's call it Roam 3. And complete that one. And then this one, let's define something here. Okay, so for number 2, let's say I want something like this. Let's call it Roam 2. Let's define the path. So let's say I want to go up, traverse segment, and altitude. And let's say I actually want to go high in the altitude. So something like, I don't know, 3,000 meters. And then we come back down to 0 meters. Complete it. Okay, so now we define a trajectory for node 1. Let's call it Roam 1. And we're going to define the path. So start from here. Continue. I want it to go sort of spiral and up and away. And it'll get lost like around here somewhere. Okay, so that's that one. And then this network, similar to the altitude one, I want it to go and come back. So let's define the trajectory. Let's call it Roam 0. So start here. We go about down here. We continue. Let's make he makes a sharp turn and he comes back. And we complete it. So one thing to take into account actually is that all of our trajectories have to be completed within the 7-hour time period. So I have to make sure these workstations traverse their trajectory in that 7-hour time frame. So I'm going to adjust them now. Okay, so then I go to the 4. I go to edit the trajectory. it pops up this menu. And so here we have the traverse time in seconds. So basically 7 hours, if you do the math, it'll show you that that's equal to 25,200 seconds. And if you divide this by 7 sections, you know, this will make the workstation traverse it in that time. So if you divide it by 7, it gives you 3600. So 3600, and actually you'll see that that's equal to 1 hour. So my math checks out. And we'll press OK. Yeah, we want to override it. And then we go to node 3, edit trajectory. So we have 10 different, so we want to divide 25,000 by 10. So that means, where is it? Traverse time here. 25 to 42 minutes. It gives me. Maybe I can copy paste this. Let's see. Yep. Okay. And then we want to edit this one. So let's see. So this is going to be in seconds, 12,600. So 3 hours 30 minutes. That makes sense. And that makes sense. And we want to override. So now we define this one. We want to make it equal to 7 hours. So then we write here 6,300. That should be 7 hours. And then we go to edit trajectory. And this is the same one as before. It's basically 12,600 seconds. That's not right. 12,000. There you go. 3 hours and 30 minutes. And there it is. All of our drones are configured for mobility and different altitudes. At least node 2, that is. So now finally we go to the application definition and we change the application that we're trying to do here. So we want to start with peer-to-peer file sharing, high traffic. And then we want to duplicate scenario. No, I pressed manage scenario, so let's close that. Duplicate. There it is. And then we want to change static to mobile. And then application is peer-to-peer. And then firewall is still the same. The rest is still the same. Press OK. And it'll give us a little loading. And then we run it. Okay, so peer-to-peer is finished running. I'm going to change my application definition. And we're doing basically the same steps as the static version of the simulation. And then we're going to go to email now. High load. Scenarios. We always have to go to scenarios and duplicate the scenario. So mobile And now we're doing email. It takes a while to save, and then I run it. Okay, so this one's pretty quick. Okay, so now I go to application definition. I go to I take off email. I put on heavy browsing HTTP. And this is the one that should be blocked. So let's go ahead and no, we want to go to duplicate scenarios. And then we go HTTP, press OK, and then we run it. Okay, that's good. So now we go to application definition one last time. We go from HTTP to HTTP high load. Go to scenarios, duplicate scenario, and last but not least FTP. So FTP, firewall, okay. And then let's run it. Okay, so finally we can begin to look at some statistics now. So let's go ahead and do that. Okay, so what you want to do is you want to look at our results tab here. And then you want to go to current project. And we unselect this one because this is the most recent one. And then you'll see that we have all of our scenarios listed here. And they all have a nice title where I know what they are. So, for example, the first one here, the workstations are static. They're doing peer-to-peer file sharing. And the firewall has HTTP, but that is of no consequence. So let's go ahead and start looking at this. So, in fact, and I don't see the server object here because it has no information to record. So let's just look at the throughput of each of these workstations. Now I actually added more information than was necessary for this, but generally this is good to have, just in case something arises. You want to have something to look at. Okay, so this is what the first graph looks like. And in fact, if we increase the performance of the CPU, what you'll see happen here is that these graphs stabilize quickly. So you'll see that this throughput stabilizes at about the 2-hour mark. It starts to look more predictable here. But if we increase capacity, if we increase the performance of the CPU, it'll stabilize quickly. So let's keep this here. Okay, so the next thing you want to look at is the static email. I have to reselect everything again. Actually, the way to do this properly is... No, I want to look at throughput here. Okay. The way to do this is I can select the first scenario and then unselect the second one, and it'll bring me back to the first graph. So then select the second, and we see here that email stabilizes much more quicker because it doesn't require much processing. And we do have strong antennas, and we do have 1 megabit per second internet. So there's no problem here. So let's keep that out here. Also, one thing about email is that we have communication with the router now, with the server, I mean. So if you'll see here, we can take a look at traffic received. Let's unselect here. And there it is. This is the server receiving the email traffic. Let's go ahead and keep that here. In the static peer-to-peer, we see that there is no option to select the server because peer-to-peer, the server isn't involved in the peer-to-peer. Then let's take a look at HTTP communication. So we see that the throughput of an individual node is actually quite small. It starts high, but then it goes really, really low, really quickly. So, let's think about this. So, as far as the nodes go, let's go back to the nodes here. There is no throughput going on. Let's look at the scenario here. Our workstations are static. We're using HTTP, but the firewall is blocking HTTP. So there it is. So our network is attempting to use HTTP to communicate with the server. So let's just look at the firewall statistics and let's see if it's receiving anything. So here we see that it's receiving some data, and our network is supposed to be using HTTP only. So we can say that the network is attempting, the workstations are attempting to communicate with the server here, but packets are being dropped left and right. And if we look at the server HTTP here, let's go to traffic received. Let's go to bytes per second here. And then I want to do stacked. So we see that the server isn't receiving anything. And that makes sense because we actually configured our firewall. Oh, oops, I unselected it. Let me reselect it. Traffic received. Server. So let's go ahead and just show that here. And that makes sense because I'm blocking HTTP. So that's good. Okay, so now we can move on here. So now we're looking at FTP. So I believe the server receives this FTP. And there it is. You can look at an average. And it's receiving, it's about 400 bytes per second. And then let's look at the individual throughputs of the nodes. And then you want to go average and you want to go overlaid. And then you want to just show that. Keep it here. Okay, so now we move on to the mobile peer-to-peer. So just so we know what's happening in this scenario, the workstations are now mobile, they're moving around. Communication is peer-to-peer, so they're communicating in between themselves. And the firewall is still HTTP, but that doesn't matter because it's communication. So let's take a look at the throughput of each one here. So, and actually I would like to compare this graph to the static version. So let's go ahead and press show. So let me get this window out of the way here. So actually these charts are all titled, so this is good for me. You'll see that in this one we have static peer-to-peer, and in this one I have mobile peer-to-peer. So we can actually see a slight decrease in the average throughput that occurs through this 7-hour time period. We see that this range is, when it stabilizes, this ranges from about 40,000 bits to 20,000 bits. And this one, the mobile, on the other hand, ranges from 30,000 to 10,000. So we see that there's a decrease in throughput. And that makes sense because a lot of these workstations go out of the range of the router. In fact, let's also look at, so I'm going to be looking at this same graph, but now I'm going to be looking at a moving average, because that gives me a good indicator. So let's say I choose a moving average of about 1800. So that's, I believe that's 30 minutes. So in the period of 30 minutes, this is the graphed throughput of each of the workstations. We see that a lot of them go to 0 for a good while. In fact, let's see if it's the same for the static peer-to-peer. So I want to actually select it and then unselect this one. And it is actually the same. But what you'll see is that each one is sort of interchanging with the other one. There is a back and forth between who gets to get the most throughput within this time frame of an hour. But and also nobody really gets to 0 for a long time compared to the mobile scenario. So let's look at the mobile again here. So if you see here, node 2, if you look at our, let's look at node 2. Oh no, what's this? Cancel. So node 2 is actually the one that goes really high in altitude and then it comes back down. So that's where we can see this green, that's where we can see that this green graph is really low connection for a very long time here. This is about 4 hours. Okay, we move on to mobile email. So that means mobile workstations using email. So here we'll see that once again node 2, this is the node that goes real high, 3 kilometers in the air and then comes back down. We see that it has a very reduced throughput. And this may be a common theme throughout the rest of this video here. In fact, the other drones, or I guess drones you can call them, that I have configured here actually go pretty far out. But one of the things that I did was, one of the things that I did with my antennas was make them high performance. So they can actually continue a connection with a workstation for a short, for a long distance. And it's both the power on the workstation and the power on the router. So that is why actually, if you look at this graph, the throughput is more or less the same. Let's compare it with at the previous, with the static email. Actually, I already have the graph out, so let's go ahead and show. Let's move it out the way. So this is mobile email, and then I want static email right here, static email. So these two graphs here are the ones I'm going to be looking at, and we see that this is actually correct. The two more or less are the same in terms of throughput, and that is because of what I mentioned, with the exception of node 2. As you know, node 2 goes 3 kilometers in the air and then comes back down, so it loses throughput. So what we see here is that as long as your workstations don't go too far out, your throughput can be relatively unhurt compared to if they're static. So this is quite interesting. Okay, so let's move on to HTTP. And once again, we see that the throughput is non-existent. It makes the first attempt, but then everything else gets dropped. So let's take a look at what's going on in the firewall. So the firewall, once again, is receiving bits, but again, it's our drones, or rather workstations, are communicating to the server using HTTP. So what's happening is, packets are being dropped again. And if you go to the server here, traffic received, bytes here, see that it's 0 here. So this proves that actually our firewall works for both cases, when the drones are static and mobile, and obviously it should. And last but not least, we can take a look at FTP. And let's take a look at each of these statistics. So this is the throughput. Let's see if I have the static version of it, so I can compare. Static FTP, here it is. So let's compare these two graphs here on the bottom right. I apologize for all the graphs, but this is an involved network, but we can do it. So we see that on the right. Let's change here. On the right, we have a static FTP communication, and we see that it stabilizes at around 800 to 600. On the mobile network, we see that there's stabilization. This is, what is this, like 750 to 250. So it dips down really quickly. So we see that the overall throughput, once again, is quite low. So, and that is actually what we expected to see compared to email communication and even peer-to-peer communication. So the overall trend is, reduced communication, reduced throughput communication. And one more thing that I'd like to mention here, I can all close all of these already. The nice thing is that I'm not gonna lose these graphs. They're always gonna be here in my scenarios menu, and I just have to go through the results and click what I want to look at. But they're here. Now I can look at delay, but you'll see that it doesn't really affect much, because these drones or these workstations are in a general same vicinity. So in terms of milliseconds, it doesn't really add much. If you move a couple of feet to the left or to the right, it doesn't really change your delay. Now if you go out of the range of the router, that's an entirely different story, and that'll certainly give you a delay, but that is more like a loss of connection type of delay, which is worse. So yeah, and that pretty much wraps up this video, and thanks for watching.